It's really a social imperative that we address, I think, the energy needs of our country in a responsible, renewable, and a secure way.
There's initiatives at Department of Energy like HydroGEN at Scale, which basically is saying, can we change our energy structure?
HydroGEN is an energy carrier, and the goal is to use it in many places as you can within the transportation and industry and other sectors in order to displace the carbon component of fueling our society. How you do it, that's a different story.
You need to be able to make hydrogen at low cost. You may need to be able to store it at low cost. You need to be able to move it at low cost, and you need to also use it. Where HydroGEN Energy Materials Network comes in is that we're the hydrogen production part of HydroGEN at Scale. It involves people, universities, industry, and national labs across the whole US. And we all have this common goal, is to make low-cost renewable hydrogen so that we can have a better world.
The water molecule is a very stable molecule, and so there are various ways with which to separate oxygen from the hydrogen. That's what we really want to do. When we say splitting the water molecule, we want to separate oxygen from hydrogen.
There are multiple pathways that we look at to make hydrogen, and one of the main ways that we look at that's kind of closer to commercialization is electrolysis.
Low temperature electrolysis is one of the pathways that I work on primarily. And in that process, we use electricity to split water. And within that, what we are looking at essentially are what materials can we use that are non-precious metal, or can we decrease the precious metal loading in order to reduce the cost.
We do material discovery, we make materials, we characterize them, but we also have cell testing, from single cell testing to stacks, and all the way to the whole system of balance of plant. We do the entire scale of fuel cell and hydrogen research.
For high temperature electrolysis, what we work on here is understanding really high temperature processes, and especially as they relate to kind of nuclear type industries.
There's also hydrogen production via photoelectrochemistry. The photoelectrochemical generation of hydrogen involves placing a device in front of a solar simulator, or up on the roof. We have on-sun solar tracker as well, so we can do measurements in both places. And watching how these devices function.
And then there's a pathway within hydrogen that's where my expertise is, and this is where we use solar thermal chemistry. We take these metal oxides and we expose them to very, very high temperatures. And that causes this material to desorb spontaneously its oxygen. And then from there, we can take this reduced metal oxide and then we can take it into a different condition at lower temperatures and expose it to steam. And the oxygen from the water molecule will spontaneously go back into that oxide, fully oxidizing it. And the hydrogen part that we want, the H2, magically floats away.
We're using theory-guided approach to discover new materials, figure out which materials we should start making that has the potential to split water. And then we characterize them, and then if they do or not, we go back, understand, using theory to help us understand why these materials work the way they do.
When somebody sees something in their experiment and they say, I have no idea why this is happening, or I think this is happening because of this, a decent simulation model may help understand why that is happening and maybe refine some of those conjectures or theories.
It's great to be focusing on how to get the best out of my machine and don't have to worry about the best synthesized materials, because I know the best experts are supplying those to me. I can supply the results to focus modelers, and that is very hard to have in a small team. So you have to reach across laboratories and institutions. Yeah.
The way that the consortium works is that there are externally funded projects, the universities, other national labs, or industry.
We have over 21 different projects across the US right now, working on 4 different water splitting technologies. And they don't work by themselves, they work with us.
The consortium allows us to essentially move the technology quicker towards a commercial application, and also allows us to make refinements and optimization to that technology, which allows further penetration into those markets. But I think every time we get to interact with the national labs, I feel a little bit smarter after I get off the phone with them.
All the information that flows between the national labs and the seedlings or even within the national laboratories that kind of fosters the entirety of the collaboration flows through the Data Hub.
One thing the HydroGEN Data Hub is built for is to enable collaboration and the sharing of this data for hydrogen materials with the public.
The guidance and vision from DOE and the opportunity to build something like HydroGEN and to direct our energy and our knowledge and resources, and their resources too, because it's public resources, into solving this problem, I think that can't be understated.